Have you ever heard of this strange possibility fact? If you put just 23 people in the room, then there's a greater than 50% of chance that two of them will share the same birthday. Sounds like a weird coincidence, right? Actually, it's pure math, and its surprising probability forms the foundation of a serious cybersecurity threat, the birthday attack. So in this video, I will explain what birthday attack is and why it matters in cryptography and how we can defend against it. So let's start with the paradox itself. So if you pick a random birthday, and the chance that the next person matches yours is just 1 in 365, pretty low. But once you have 23 people, then you're no longer just comparing to yourself. You are comparing all possible pairs in the group. So the number of comparisons grows really fast. With 23 people, you get 253 unique pairs, and that's enough to push the chance of any birthday match over 50%. So it feels counterintuitive, but mathematically it checks out. So that's what makes it a paradox. And let's move to cybersecurity. So in digital systems like file verification, blockchain, and digital signatures, we rely on hash functions. So the hash function takes the input of any size and compared to a fixed size string, a kind of digital fingerprint. Ideally, different inputs should create different hashes. But here's a problem. The total number of possible output is limited. And just like the birthday scenario, with enough random inputs, you eventually get a collision. Two different things with the same hash. So in this case, it's XAA3, and this is also the one, but they are completely different. So thanks to the birthday paradox, you don't need to try all possibilities. If a hash function outputs n bits, then you only need around 2 to the power of n divided by 2 attempts to find a match. So for SHA/256, then the n will be 256. So you only need 2 to the power of 120 and 80. So it's not easy, but it's still easier than 2 to the power of 256. It's half. And how does the attack works? So imagine someone create two PDF files. One is a normal looking document, and the other is the malicious contract. So they carefully design both files so their hashes are identical. So this is all identical. And they show you the first file and get you digital sign as hash. So someone remembers this hash. And then they switch it in the second file. Because the hash is the same and your signature verifies even though the content had changes. So I only recognize the hash, which means these two files are the same. But it's not. So that's the birthday attack in action. So there's a collision to full signature verification because they only recognize the hash. They don't know what's actually inside of the document. So birthday attack isn't about cracking password. It's about using the probability to sneak fake data past the system defenses. So it's basically you have the different hash, right? And how to protect yourself. So use longer hash output algorithm like SHA-256, SHA-3 makes the collisions much harder to find, and for signatures and authentication, use the HMAC or other methods that mix in a secret key. So remember, as hackers don't always have to be smarter than you. They just need to do math on their side. So your job is to design a system where math works for you, but not against you. Thank you so much for listening.